Welcome to Book Doctor Technologies channel. In this video, we are going to look at certain questions on advanced algebra and calculus. The first question we shall look at is to evaluate the limit the square root of a plus h minus the square root of a all on h as h approaches 0. As h is the denominator, when you input the h, the fraction will not be defined, and as such we have to manipulate the expression a little further. So let's copy out the expression. The square root of a plus h minus a all over h. We shall rationalize the numerator by multiplying through by the conjugate of the numerator. The conjugate of the numerator is the square root of a plus h plus the square root of a all over the same expression, a plus h plus the square root of a. When you multiply the numerators, we shall employ the use of the difference of two squares. So the square of the first one minus the square of the second expression, and that will yield a plus h minus a. Multiplying the denominators, we just write the expression as h in bracket square root of a plus h plus square root of a. Simplifying the numerator, the 8 will take care of the other 8, and this reduces the numerator to just h. We'll have h into bracket the square root of a plus h plus root a. The h can cancel out, and the expression we're left with 1 on the square root of a plus h plus the square root of a. We will now take the limit of the remaining expression. We will now evaluate the limit of 1 on the square root of a plus h by the square root of a as h approaches 0. As h approaches 0, the expression will reduce to the square root of a plus the square root of a, and this can be simplified to 1 on 2 root a. Let's look at another question. The sum of the first and the third term of a geometric progression is 14, while the fourth and the sixth terms are in the ratio 1:4. You have to find the common ratio and the fifth term. So let's start with finding the common ratio. The first term, u1, is a. The third term, u3, is ar 3 minus 1. That will be ar squared. The sum of the first and the third will give us 40. So that will give us a plus ar squared is equal to 40. We'll leave this one and mark it as equation 1. Now, the next information is that the fourth and the sixth terms are in the ratio 1:4. The fourth term, u4, can be expressed as ar cubed, and u6 can be expressed as AR raised to the power 5. Since they are in the ratio 1:4, we can express it as AR, let's check, AR cube is to AR raised to the power 5 equal 1:4. Ratios can be expressed as division. So this will be AR cube over AR raised to the power 5 equal 1/4. The A's can cancel out, simplifying the R cube over R raised to the power 5 will yield R raised to the power 2. 1 on R raised to the power 2 equal 4. Cross multiplying, we have R squared is equal to 4. So R will be equal to the positive and negative square root of 4. So our common ratio will be positive or negative 2. We are to find, let's go back, the fifth term. In order to find the fifth term, we need to identify the first term. Our first equation was A. Let's go and pick that equation. A plus AR squared is equal to 40. But R is equal to positive or negative 2. Since both negative 2 and 2 will yield the same result because of the square, we wouldn't bother about which number to throw into this equation. We can either use the negative 2 or the positive 2. So this becomes A plus A into 2 squared is equal to 40. We are going to have A plus 4A is equal to 40. This will yield 5A is equal to 40. Simplified further, the first term will be 8. In order to find the fifth term, we'll throw in the values of our A and R. U5 is equal to AR power 5 minus 1. And that will be AR power 4. First term is 8. Second term, so the common ratio, we can pick either the 2 or the negative 2 because the power 4 will yield the same results. So 2 is the power 4, and that will yield 128. Let's move on to the next question. Use the Euler's diagram to determine the validity of the following argument. And the premise is that no prime numbers are negative. The number n is not negative, therefore the number n is a prime number. We will let the letter P represent prime numbers. And the letter N represent negative numbers. If no prime number is a negative number, this means the two sets are disjoint sets and can be represented by the two circles as illustrated below. So let's call this set P and this set N. Now let's look at the conclusion and see whether it is valid or not valid. The number n is not negative, and therefore the number n is a prime number. If the number n is not negative, then the possible places that the n can be is inside P, or it can also be outside both P and N. So these are the possible places that N can be represented. The statement is valid if and if only the N can be found in the circle P or the position N1. But it is not valid when the N is at the position N2. So the overall effect is that the conclusion is not valid, because for the validity of the conclusion to hold, the statement should agree for all possible solutions for all possible positions of N. Even if one position does not agree to the assertion, it leads to the statement not being valid. Thank you very much for watching. There are other videos you can watch on some selected sample questions on advanced algebra and calculus. Do not forget to subscribe.